So I think it's 5 minutes after. I think we can get started now. So thank you all for joining us today. We continue discussion about the chapter 2 on Python Data Science Handbook, and we are still on Numpy. So last week we did a lot. We discussed the rationale why we need to use Numpy. So if you go up to the slide. So we started talking about arrays. Python comes with array, and for us to use anything in Python, we need to convert that thing into sequence of numbers of array. But Python array is so slow. We said, okay, then the Numpy comes, and we are now using Numpy. We said the Numpy was written in C because C is so fast. And also we said what Numpy can do. Numpy provide array, which not Python array, but called ND array, which provide efficient multidimensional array, providing first way to do some kind of array-oriented mathematical operation and somehow broadcasting, we'll see. And Numpy, which is different from Python array, it comes with some mathematical functions. So Numpy, you can calculate, like, for example, cos, sine, tan, many all those things. It comes with many linear algebra, random generator libraries, and also it provides some kind of API. We also understanding of data in Python. We said that data in Python called dynamically typed in, and it contains many overhead that allows Python to be slow. Yeah, we also see how Python integer is not more than an integer, but with some kind of overhead, more or less also with the lazy. We also discussed that fixed type array in Python. So since Python array can contain many kind of data type list, but we have fixed type array, which is from this array module. So on top of this array, fixed type array, the Numpy come on top, build on top of it to create Numpy array. So this is Numpy array, np.array. You can see the array object is from built in Python. So Numpy now built on those built-in array object from Python. So we have, this is how we create a Numpy array, which is called ND array. Yeah. So that's motivation we talk about. We discuss a lot how we can create many kind of built-in Numpy method, like np.zeros, create array with zeros. We say np.ones, create array with all with one. np.full, create an array with given number, for example 3.14, and give us 3 by 5. We also discuss np arrange, which also just like range in Python, which for example start from 0 to 20, but with step size of 2. We also discuss the linspace. So yeah, right. We also discussed the non-standard Numpy standard data type. We said Numpy has its own standard data, has its own data types on top of Python. So for example, here we said that you can use int16. For example, you can specify I for integer, U for unsigned integer, and stuff like that. So this is telling us that Numpy on itself has its own data type. Yeah, so that is its Numpy standard data type, but it builds on existing data type in Python. So that is what this means. Apart from that, we also have, we discuss how you can convert data type on existing arrays. So if you have an array which is an integer, you can use AS type to convert to this. Now, where we stop the basic of Numpy array. So this is the basic of discussion of Numpy. We have discussed what attribute, I mean, for any given Numpy array, there is a size, there is a shape, memory consumption, the data types of array. And these are some of the things we will continue discussion. Attribute of array, number 1, in how to index array, number 2, slicing arrays, how to slice array. So given array of given size, slicing array means picking some part of the array. Indexing array means taking some numbers individual. So if we say we want to index an array, so you want to pick a particular number. But when we say slicing, we want to take some part. And also reshaping array. So given a particular shape, we'll see how we can reshape. Joining array means concatenation. So when we say joining array, we mean how can you, given 2 arrays or given 3 arrays, how can you join them? That is called concatenation. So we started the first one, which is attribute of array. So given any array, we discuss here that for example here, we said 0D arrays, given a single number is 0D array. But when we have an array that has 0D arrays as its element, so for example here, this is the element of this, then it is one-dimensional array. We also discuss if you have one-dimensional array as the element in array, then it is two-dimensional. All this one we discussed. So we also said that Numpy comes with a function that allows us to find the dimension of array. So given this is an example, random seed, NP the random integer. So this is telling us to generate integer, 10 integers, right? So print X, then we find the dimension here. So here it's telling us, oh, okay, this is it. So here it's telling us this is the array we generated, but using random integer. And this is the dimension, which is 1. Yeah, of course, this is the 1. We also have what is called shape of an array. Now we are under attribute of an array. So attribute of an array, we have dimension, we have seen, then we have shape. So what is the meaning of the shape of array? Shape of an array is the number of elements in each dimension. So given this one, in this dimension, we have, who can tell us the dimension of this one, the shape of this array? Who can tell us the shape of this array?
2 by 4.
Right, 2 by 4, because we have the dimension here is 2, we have the this one is, so this is 2 by 4. Right, but last week someone made a question on, I will explain that one as well. So here I'm just revising this session, so that is why I'm moving faster, so we can just get up to speed. So here, this is an example. Here we have an array at the same as we have seen. This is Numpy array. As you can see here, we have this one. It does have 5, 0, this, and we want to see the attribute of this array. Then we say, okay, let's look at it. So number 1 here, you can see the shape is 6 by 1. So here, all right. So let me command these ones so that we can also look at them. Where icon size, right? Okay. Right. So here, this is the shape. I will explain this one more now, because someone last week asked and did it explain, I think, quite well, that maybe I would need to explain it now. So item size, this is telling us how many items we have in the array, which we have 6. Data type is integer, they are all integer. Item size, the byte in byte is 8 bytes. So each item, what is the byte? Because it's integer, and so integer are stored in byte, 1 byte, 8 bytes. So because each, yeah, so n byte is 48 by number of the number times 6, which is given us, and the dimension is 1. So there is one issue with this stuff. So let me give an example here. So you see, this definition, we should consider this definition. Okay, shape of an array. Shape of an array is the number of elements in each dimension. But shape of an array called shape that return was a tuple with index having number of corresponding. So the shape of an array, it means what it returns is a tuple. All right, let me give you an example so that we can understand this more better. So here is A equals to 2. And I can say here is type of A, type of A. What is type of A here? Who can tell us what is type of A here? What is type of A?
An integer.
Yeah, an integer, right? Okay, so right, an integer. So let me tell you, see this one. A is equals to 2. So what is the type of A here? What is the type of A here? What is type of A here? Who can tell us? So A here is a tuple. So let's look at it here. A is a what? Tuple. So in Python, a tuple, okay, I can do like this. In Python, what makes something a tuple is just this comma. So let's look at what is this type of tuple. So now let me remove this comma, this stuff. Let me put this 3. Can you see 3? Or can you see this one? So let me again ask Python, what is the type of this one? Can you see this is still tuple? So a tuple, what makes anything in Python tuple is this comma. So this is just to make this thing like more, you know what I mean? Make it more concise. So you can even remove it. So what this is telling you, the dimension. So here it means when I have this, A, how many numbers that A contains now? A contains how many number? 1, right? So if I have this, A it contains only 2. So it means I can have something like this. So this means that A equals to, no. A equals to 2. These are the same. Is that correct? Are these two the same? The one at the top and the one A equals 2 with comma, are they the same?
Yes.
Sorry, sir. Does that mean that the open and close bracket are optional?
Exactly. And tuple, exactly. So this is telling me this, and this are the same. So this is telling you that A is contain a single number. A single number. A is a single number. It's not telling us here A contain 2 numbers. We just using bracket 2 because this is telling us this is just A is 1 number. So what this is telling us that if you look at the shape, what shape returns is a tuple. So this is telling you that Numpy array have an attribute called shape that returns a tuple with each index having the number of corresponding elements. So with each index having the number of corresponding elements. So this is telling us that now, let me give an example more. Where is the example that I can give? Okay, yeah, let me give you an example in top. I think I have it. Yeah, so you look at this one. This is the shape, right? 2 in this and 4, right? Then it has 2 dimension in this and 4 dimension here, right? But what about this one? It has only what? 1 dimension, which is what? 6. So writing 6 here, look at it. It does not mean it's telling you we can say 1 by 6, because in tuple, writing only single number, you write it at this way in tuple. If it is tuple, if you want to write a single number in tuple, you just rewrite it in this way, A, 2. But also you can write it in this way. This is how a single number is represented in tuple. Does that make sense?
Yes,
Yes,
sir.
So this is telling you that the dimension of this one is 6. Do you understand? But for us to write a 6, it's just we need to put 6 and comma, and this is how tuple is returned. Anyone with question, ask question if you have. So you can see the shape is tuple. If there is only 1 dimension, the shape will be 1 number and just blank after comma. For 2 plus dimension, if we have dimension which is more than 1, there will be number after the comma. So that is it. So you can see from here. So more example on tuple. I mean, this is another example. So here I have a Z, which is NP.array. This one, as you can see, this is right. So you can see this one. How many dimension is this one? So we have NP.array. Then I define an array. So you can see this opening this square bracket is the start of dimension. But you can see inside the dimension, we have only single number, which are 0 dimension. So when the element in the particular dimension are 0 dimension, then that is is 1 dimension. So you can see this is this one is not a dimension, but a number. This is not a dimension, but this closed one is end of dimension. So if we print this one, it will give us 2 by 1. But what about this one? We have start of outer dimension, but inside it, we have 1 dimension. Because look at it here, this is just a single number, not inside the dimension. We have another number inside the dimension. So it can be like 2, 3 more, or we can say, okay, this is another example. We can leave it like this. Or like this. Can you see that? So, but I'm just giving an example so that you can understand what that does mean. So here you can see we have 2. So here we have that. We can have something like this. We can have 2 by 1. Can you see? Because it's the dimension is 2 here and here is 1. So this is an example we discussed last week, but I felt like I've not explained it well. So that's why right. So this is just continuation of the example. So here we have this. You can see NP the random, the integer. So we specify the array to be 3 by 4. That is 3 by 4. And here we look up the dimension, which is 3 by 4, and the size or other info. The dimension now is 2. Any question? So this is the same thing. If you have 3 dimension, it will report. So this, let's look at this example. So here we have this. So we say 3 by 4 by 5. And now when we look at this dimension, we have 3 dimension, of course. Then you can see the shape is 3, 4, 5. Okay, so this is still the same. So any question? So this is where we continue with the last week. Any question before we continue? Okay, so let's continue. So array indexing. So now we have finished looking at the attribute of an array. That is what is the shape, what is the dimension, what is the what else, the data type and stuff. So let's look at the array indexing. So when we say array indexing, it means we want to pick one element from the array, a number or anything like that from the array. So here we have we create an array using random integer of size 6, and let's look at the array. So this is it. So we want to pick up x of 0, 1, and so this is it. So you can see 3 because that is the first element here when we have that. So when we have this one, the first one is 3, this one of 0. So x of 0 here, we'll look at, let's look at f of 0. This one of 0, what is it? Is it correct? Okay, let me print this, the x1 and 6, what is happening. Yeah, so you can see x of 0 is 1. So if you say x of -1, we are telling the indexing to start from the end, which we have seen in Python is more or less the same. So what about indexing in multidimensional array? So this is single dimensional array. We just provide a single number. So what about if we have multidimensional? So you can see here we have 2 dimension, multidimensional. So in this case, you provide 2 numbers. We do indexing with 2 numbers. So here it's telling us get the first, the second dimension and take the second number. What would be the output of this one? Who can tell us?
8.
8, right? Okay, let's look at it. Exactly 8, because the second one and the number, the third one, so 0, 1, 2, which is 8. Right, so Python start when we say this one, it gives us the first dimension, which is, and the first number, which is 1. So also this is an example of 3 dimension. You can also modify the dimension. So if we have 0 for 0, it means we are looking at the first dimension and the first element. We modify it, it becomes 2. So here we modify this to be 2 instead of the previous number. So any question before we go to the slicing? Question, please. No question?
Yes. Yes, sir. Just come again. The one you did last.
Okay. This one?
Yes.
Okay. So what this meaning is that, so if you look at this, let me see, where it's x2, okay. Let me look at the x2. X2, why do you define x2? I don't know why you define the x2. Oh, okay, I think this is the x2, right? Oh no, this is the x2. We have to go back. X2. Right, this is the x2. So you can look at x2. This is it, right? Here we have these numbers. This one, right? This is x2. So what we said here, there is let me print the x2 stuff. Yeah. Okay. Right. Already modified the x2 now. It changes. So okay, let me take the value of the x2 and see what it is. Yeah, I think this is what we kind of expect. So let me check it. Okay. Right. So I think we can see it here. Oh, okay. Know how to deal with you guys. Right. So let's comment this, guys, and let's call what is x2. So let me call s2. Call it like this. So we can see here we have this 9 to this is the first dimension, this is the second, this is the third, right? So now here we said we want to modify this. What this is telling us, so this is telling us that the first dimension and the first number. So previously, who can tell us what this number is? X0 and X200. What is this number?
That's 9.
That's 9. Is that correct?
Yes.
Okay. So if it is 9, when we say here is equal to 12, what are we doing here now?
We are replacing the first element.
9.
That's we are replacing 12, right? 9.
Okay.
Yes.
So let's look at what happened. So let's look at what happened. Can you see we replace the first element to be 12? So this is it. Does that make sense?
Yes.
Okay, cool. So let's go on to the next one, which is slicing, array slicing. So now we have seen indexing. What indexing means is just like we are picking one element from the particular array. Now let's look at indexing. Slicing. So what we mean by slicing is to take some subset of the array, right? That is what we call slicing array. So as Python, we know what we do, like start, stop, and step. So this is start from here, stop here, and step means how many number that it will increase. But by default, it starts from 0 and the step size is 1. So let's look at this one here. We said this create an X, which is this. You see that? Now we want to slice this array. So here, when we put this one, it means we start from the beginning up to 5. So this 5 does not include. Who can tell us what will be the new? What are we subsetting? What will be now the subsetting? Who can tell us?
0 to 4.
0 to 4, right? Okay, let's look at it. Yeah, 0 to 4. What about this one?
This one is 5 to 9.
5 to 9, right? So yeah. So when we put this in to the end, what about this one?
4 to 6.
Right, let's look at it exactly. What about this one? Who can tell us? What about this one? Who can tell us? Come on, guys.
Okay, this is going to give us from 0 to 9 with the step of 2.
Okay, so this is telling us, remember I said we have 3 numbers when you are doing slicing as well. So this is what is happening. So we say start, stop, step. So what we mean by step is like, this is how it will increment. But when we say here, if you look at it here, we do not provide any step. We provide only the start and stop. But the step here, we didn't say the stop. So the step is by default 1. So that is why here we said from the beginning to 5, it is 1, 2, plus 1, which is by default. But when we want to increment by step, so here we say, okay, start from the beginning to the what? N, but with step of 2. So this will give us, what will be the answer now? Who can volunteer?
It's going to give 0,
Okay, 0,
2,
2.
4.
All right, 0, 2,
6.
4. Okay, yeah, this is it. But what about this one? So here you can see when we leave anything empty, it means it starts from that level. But when we put here 1, it starts from 1 and we step up 2. Right, any question? So, but when we provide negative number here, it means we are starting from last, counting from it. We want it to start from the last one. So here it reverses all the elements when we have this. So this is one way to reverse your array. So you just provide this, and you say this is how you reverse. This is one trick if you want to reverse your array element. So you provide -1 and stuff like that. All right, so let's go on. Now we have seen how you can do with that. So what about multidimensional subarrays? So here we can see here we only look at slicing using only one dimension array, which is obvious what we have seen in Python. But what about slicing a multidimensional array? So it also works with the same way, but what we do, multidimensional work with the same way with multiple slices separated by comma. So this is what it means. Multiple slices separated by comma. Remember in indexing, we provide also two stuff from the start and the beginning, but here we provide the 2. So here let's look at x2 here. So here we have x2, right? This is this, which is 3 by 4. Now, who can tell us what will be this one? We want to slice this array. When we say we want to slice, it means we want to take some part. We are not indexing. Indexing means we take one number, but slicing takes some part. So what will be the answer here? Now, who can tell us, who can guess the output of this one? Who can guess the output of this one?
So I think it should be 2, 3, 2, 3, 8, 2. Yes, 8, 2.
Okay.
Then 8, 8.
Why you say that?
Because we are taking 2 rows and 3 columns.
Which 2 rows? The 2 rows start from top?
No, it's starting from beginning, and it will not include 2.
Okay, it will not include 2. Okay, let's look at it exactly. So here you say, you can see the first one is row. So this one, when it's empty, start from the beginning and end at 2, but the 2 is not inclusive, it's exclusive. So it will start from this row, that is 0, 1, but not included 2, right? And this is column, start from the beginning, take 1, 2, and so let's look at what will happen here. Can you see it?
Okay. Okay.
So this means 0, 1, 2, but not including 3.
Okay.
Does that make sense?
Yes.
What about this one? So here it means it will go from the beginning, but here we are indexing, we are the column, every other column. So here it means we provide the step parameter, but here if you look at it here, there is no. So when there is no step parameter, it just increment by 1. So it means we are taking the first one, then the next one is second, the next one in incrementally 1 by 1. But when we don't want to, we want to take this one, and we don't want to take the next one, we want to take this one, and we don't want to take this one, we want to take the next one. That is, you provide the step. By default, the step is 1. So this one is the same as this, like this, I think. This is the same as this. Let me see whether that's. Can you see? Because I said the step size is now what? 1. But by default, the step size is 1. So you don't need to specify that. But when the step size is not 1, you can specify. So here, let's look at this. So can you see from this up to this? But we want to take the first one. Then the step size is what? The step size is 2. It will not take this one. It will take this one. Can you see? But it will not take. Does that make sense?
Yes, sir.
Question, please. Ask question before we continue. All right. If that makes sense, then this one will reverse the whole dimension. And as you can see, this one will just reverse the stop. So that is slicing. Okay, there's one common stuff. So sometimes you may want to take only row or only column given this. Okay, for example, here I have this, and I want to take only this row, or I want to take only this column. So here I'm slicing, but I'm slicing in terms of row or column. I'm slicing, I'm taking row, particular row, I'm taking particular column. So this is how we can do it. So here, if you can see, this is our array. Maybe we want to take this, right? We want to take this one, 12, 8, 0. So you can see here, I can put this empty and this empty. It means the whole, right? It means the whole. But here, what we mean, we combine with slicing and indexing. So here you can see here, I put this, but this one is indexing, right? Indexing, taking only one, the first one. Here I'm not providing parameter, I mean sequence, like I can say, okay, from one to 3. I'm not providing this. If I provide this indexing, this kind of thing, it's telling me that take from 1 to 2 or from 1 to 3. But when I just provide a single number, can you see a single number? So this is, so what will give us this one? Who can tell me this one? What will get at this one? This, what will give us this one? Come on, what will this give us? So the first one here, you can see it's telling us all rows, right? All rows. And here it's telling us what? First column, let's look at what happened. Can you see 12, 8, 0, right? What about this one? What will give us the first column, the second? Can you see that? So this is sometimes you want to take a particular row or a particular column. So you can change this one the way you want. For example, if you want to the column, you can take this one to here and something like that. You can arrange them the way you want. Any question? So also there is one thing here. If we have this for rows, if we have this, so you look at it here for columns here. I mean, okay, let me show you this what I mean by this, so that it will be more understandable. So if you look at our X here, I have this column, right? X 12, 8, 12, 8, 0. What about if I want to take this 12, 8, 0? That is this column. I want to take only this column. I want to slice only this column. What you can do is this. You can say X, all the rows, means from the start to the beginning. When we remove anything, it means all. But here, I'm not specifying range of column, but only one column. When I say 0, it means first column. So here it means first column. But here, I say all the row, but what? This column. So here, when you are indexing column, you put it in this way. But when you are indexing row, so here it's telling me that, oh, okay, I want all column, but what? First row. So let's look at this one, what will happen? Can you see? 12, 3, 8, 12, 3, 8, 8. Can you see that? So if it is row, not column, we can just use this one. X to 0, X to 0. So it will give me just the row. Just give me X to 0, equivalent to this. So, but not in the column. Does that make sense? So
yes, sir.
So we understand now how we can slice, take a single column or a single row, and we understand how we can slice. So we can slice using this is a slicing structure. Given we use this dot, this stop, and comma, that is called slicing. So we use comma to separate slicing between the row or column. Yeah. So that is all about slicing. Any question before we move on? Okay. So let's look at something in Numpy, which is called copy and view. If you remember, there is something we discussed, I think, in Python, that when you copy something, is it called copy or modify or something like that in Python? When you copy something, then the original one, if you modify, is not affected. So here in Numpy, we have what is called copy and view. So let's look at this example. So here I have an array. Can you see the array? It contains 1, 2, 3, 4. And now here I copy the array. And now the copy is, I store it inside what? X variable. Now here, what am I doing here? Who can tell me what I'm doing here? I have array, this, and I have array 0, 42. What am I doing here? Who can tell me?
You're modifying the first element.
I'm modifying the first element, right?
Yes.
Okay, now let's look at it now. Now, if you look at it here, because X, but X is a copy of the array, original element here of this array, right? X is a copy, right? So what about if now I modify the original? Will the copy be affected? Who can give me? Eh?
No.
No, right? They are separate things, right?
Yes.
They are separate. You can see when I modify it, I print the original one that I modify, which is 42, but the copy here is still 1. It doesn't affect. So that is called copy. Now, the copy on the data and any change made to the copy will not affect the original array. And any change made to the original array will not affect the copy. But look at this one. I use what is called view instead of copy. View. What this means is that if you change the original array, even the copy, the one you copy will change. Can you see now I change the original array, but the view one also changes. That is something different between copy and view. Copy and view. Now the question is this: when I have my array, and I take some subset of it, does the subset a copy or a view? Do we all understand now what is the meaning of copy and view? Answer me this question. Do we all understand what the meaning by copy and view?
Yes.
So copy, yeah, copy, it means even if you copy something and you modify it, it will not affect the something that you copy, but view that. So the question I want to ask you is that when we subset an array, does the subset, if we change the original, will it affect the subset? That's the question. Do you understand the question I mean?
Yes.
Yes, I understand.
So who can give me an answer?
Yes, it's to affect it.
So here we said sub-array has no copy, so it's view. So one important and extremely useful thing to know about array slice is that they return views rather than copy of the array. This is one. So here it means we have this our array. This is our array, right? This is the array, and here I'm subsetting it. I'm subsetting. Can you see? And I'm putting it in this x2 called subset, and now I print subset is 2, 3. This I subset it. But now when I modify the array for the original one, can you see that? Or when I modify the subset here, it's 999. Does original one will be affected?
Yes.
Look at it.
Yes. Yes, it will be affected.
Can you see it? It is affected.
Yes, sir.
So that means, do you understand the logic I want to drive?
Yes.
Yes, sir.
So,
Yes, sir.
So view, if you do subset and you modify the subset, it will affect the original array. Does the point drive home?
Yes.
Okay.
Yes.
Okay, cool. So any question? So this default behavior is actually quite useful. It means that when we work with large data set, we can access and process a lot of stuff. So this is basically what I want to say. Cool. So let's go on to the shape of array in Python and NumPy. So before we go to our reshaping, now we have seen how in some of the stuff we can do with the array. We can do slicing, we can do indexing, we can also find different kind of attributes like the dimension, the shape and stuff like that. Before we move on to the reshaping, if you have questions, feel free to ask before we move on. All right, so it means there's no question, and let's go on. So what is the meaning of reshaping? So we know what shaping is shape of an array, right? We know what shape. So it can be like 2 by 1, 3 by 2. But given a shape of an array, you can reshape it. So because if you remember in your mathematics 1301 or whatever you call it, when we have, for example, matrix, you can see when you want to multiply matrix, sometimes for you to multiply two matrices, they must satisfy one condition. Who can tell me?
Must be in the same dimension.
Exactly, they must have somehow the same dimension, right? So it means when you have two arrays, sometimes you need to reshape the array to become in some kind of dimension that will be able to do some kind of mathematical operation with it. Just an example that I gave you in mathematics, if you have two matrices, if this one has a dimension 2 by 1 and the other one has a dimension 3 by 3, they are called incompatible. They are not compatible to be to maybe do some kind of operation like multiplication of them. So also this is actually with an array. So if given an array, you may sometimes need to reshape it. So here we say reshaping means changing the shape of an array. The shape of an array is the number of elements in each dimension. We see by reshaping we can add or remove dimension. So by reshaping, what we mean by reshaping is we can add or remove dimension of existing. So let's look at an example. What is the dimension of this array? Who can tell us? Who can tell us the dimension of this one? What is the dimension of this array?
It's one dimension.
It's one dimension, exactly. It's one dimension. What about this array? What is the dimension of this array?
2 dimensions.
Okay, 2 dimensions. Now, so if this is 1 dimension, so let me look at this way. Okay, so let's look at this one here. We can say, how can we find the dimension? Who can tell me how can we find the dimension of this array? What is the function that we use to find the dimension?
Dim.
Ndim. Okay,
Yeah.
Ndim. All right. So let me look at the dimension. So you can see the dimension is 1. This is it. But I want to change this dimension maybe to 3 by 4. So what we can do is this. So we said we take the array, we say reshape, and we put the dimension we want, 4 by 3. When we say this 4 by 3, let's look at what will happen now. So can you see it? 1, 2, 3, 4. This one dimension up to 12. Can you see it? It is now which dimension it is now? Who can tell us?
This 1.
Is dimension 1?
This 2, I mean.
Okay, 2, right?
Yes.
Okay, let's look at it if it is 2. Can you see it's 2? Now, what is this, the shape of this now? That is what we have just seen now, which is 4 by 3. So this is called reshaping. But we can do also another way to find the shape or reshaping. So you can see here, I can say NP because this is a Numpy object, NP the reshape. I can now put the object here, the array, and now put the shape size. Can you see the difference? Here, this is the difference. This is it. So I can say NP, the reshape. I put the object here and put the tuple. So here is tuple. So the reshaping size, remember the reshaping size will always be a what? Tuple. What we mean by tuple is something in brace with comma separated, comma separated. This is tuple. So this is it. Any question? Here we have NP the array. We have 2 by 2 dimension, and I want it like to. So here, so here, who can tell me what will be here now? Which dimension I want to change now? Okay, let me use this.
Converting it to 1 dimension.
Eh?
You're converting it to 1 dimension.
Okay, let's look at it. Okay, excellent. So, so you can see this one is, how many dimension is this one? 2 dimension, right? So let's look at this way. Let's look at this. So here, NP the reshape, we put the array and we put 6 here. Let's look at it here. No, I'm not talking about you guys. Can you see it? 1, 2, 3, 4, 5, 6. So this is an Numpy array, and now we reshape it to a single. Yeah. So that is how we do reshape. But also, yeah. So we can also do something like this. So here you can see I define an array using arrange, and now I say grid 3 by 3, which give me 3 by 3. But essentially the first array is 10 is this. The first array is this. Let's look at it. No, not you guy. This guy. So can you see it's 1 to 9, right? But we want to shape it 3 by 3, which gives us this. So, but you can also do it in this way. So here you can see, because if you look at it here, I create an object here, and it returns the result, and I say, okay, the result that's reshape. But you can also do this way. You can create the object, but you can see this np.arrange 1 to 10, it will return an object. Then you call reshape on top of it. Do you understand? Because this is a method of NumPy object. So you can do this in one liner. Do you understand the difference between? So this one we did it in 2 lines, but you can do this stuff in 1 line, because the return object is NumPy object, so you can still call it on it. Does that make sense?
Yes.
Okay. Let's look at it. Another example. So this is 1D, and here we are converting to 3D. There we convert to 3D. So if I reshape to 2, 3 by 2, which is 3D. So we can see that you can see it. This is 3D stuff. Yeah. But can we reshape to any size? Can we reshape? This is another good question. Can we reshape to any size? Who can give us an answer? Can we reshape to any size?
No.
Why?
No.
Why?
The number of elements.
Yeah, it depends on the number of elements we're looking at.
Exactly. So here we have 1, 2, 3, 4, 5, 6, 7, 8. So here, can we reshape this one to 4 by 2?
Yes.
Yes.
Can we?
Yes.
Okay,
Yes.
let's look at it. 4 by 2, yes. 1, because like we have how many elements? 8, right?
Yes.
So you remember your materials. Yes, 4 by 2 we can reshape it because we have stuff like that. But can we reshape this one to 4 by 3?
No.
Huh?
No.
Why?
4 by 3 requires 12 elements.
Okay, so if you look at this one, can you look at what will happen? So this will not work, right? So but 4 by 2 will work because we have the stuff needed. So that's so yeah. So another common reshaping pattern is the conversion of one-dimensional array into two-dimensional array. So if you remember, this is 1 dimension, right? This is 1 dimension, right? So if you look at it here, what is the dimension? It's 3 by 1, right? I mean, the
Yes.
shape. The shape is 3 by 1. We all understand why we have 3 comma only. We all understand that by now. Does anybody has question with this? Why the shape is 3 by comma only? Does anybody has question with this? Does anybody has question with this? Ask question if you have, please. So this means that nobody has question. So this is 3 by comma 3 is it has, if when you see this, it means it just has 3 the shape is 3, which is just dimension 1 with 3 elements. But we can reshape it. How can we reshape this? So if we can see this one. If you look at this one here, when you have this, sometimes we need to reshape it to be maybe 1 by 3, 1 by 3. So that is called row vector via reshape. So here we have this the same example we can reshape 1 by 3. So here we can see here when we reshape it, it will become 1 by 3 like this. The shape is 1 and 3. So this means that now what is our P? Let's look at it. Okay. So now let's look at P. No, I'm not calling you. Look at P now. Okay, let me explain more. So let's look at this one here. So here we have X is given by this. Z is given by this. Let me look at what is the type of Z now. What is the type of Z? It's Numpy array, right? What is Z itself? Let's look at the Z. Let me show you Z. Can you see Z? Z is just Numpy array. What is the shape? The shape is 3. It's only 3. Can you see that? The shape is only 3. But I want you to notice something. Here, look at it. This is array, and it's only one dimension because the element here. But when I want to reshape here, I want to reshape this one. So here I have tuple. I reshape. This is the same example 1, 2, 3, and I reshape it here. So look at the output here now. P output P. Look at, is it this P? Is it the same with this P? After reshaping, because the content is the same. Is it correct? The same?
It's not the same.
So what is the meaning of this? Who can tell us?
They're having different shape.
They're having different.
Because of the angular brackets that are added.
So they're having different shape. So this one is 1/3, and the other one is just so this is it. So that is, sometimes you can see when we come in machine learning, you can see they will always, once they want to do multiplication, they will try to reshape it so that it will have like 1/3, so that they will do some kind of mathematical stuff. So just look at, understand what does that mean. So increasing the dimension, we can also use a new axis. So increasing dimension using new axis Numpy is used to increase the dimension of the existing array. So here we use reshape, but we can use new axis. So here you can see we say new axis, NP the new axis. Then here in the second one here, we say, okay, let's look at what will happen. So now here it means our X, we still the same thing is now 1/3, we add a new axis. This is the same example that we reshape with 1. It means we add a new axis. It is now 1/3. So let's look at it. The shape now is, you can see 1/3. We add shape here. But to add the shape without using reshape, we can use this new axis. Where do you want to add the shape here? In the row here? But because here, if you look at this one here, let me remove this. Let me comment this one here. Let me show you this. So you can see here, we have 3 here, but the dimension here, we have 1, 2, 3. So that's why we have 3, right? But when we reshape here, we said 1, here we add 1 to be here in the row, in here the dimension, and we have 3. Now we reshape it to be in the shape that we want to see it here, 1/3. So this is a good shape that we always change. Sometimes when we have this shape, we will change it here. So this 3 is not telling you about the dimension in the 0 dimension, but it's telling you about the dimension by here. Now, it means we are adding one more dimension here when we say this reshape. When we add this one, we're adding one more dimension. So if you want to do that, you can do this with NP the new axis and just call your X, your element here, nothing, it will add the new dimension. So here we are adding. Also, if you want to add in column vector, you can do this new axis here and add it here. So this is basically what this is telling us. So here, if you look at it here, we have X reshape 3/1, and we can do that. So this is just a way to reshape into a column vector or row vector. Any question? So that is what is called unknown dimension. So this one allows us to provide unknown dimension. So here, if you look at it here, we have this array. How many elements do we have here in this array?
It's
8. Now, when we say reshape 2, what's supposed to be here?
4.
4, right? But if you just put -1, Numpy will automatically reshape it for you, will automatically suggest what you mean. So this is 2/4. Can you see it? 2/4. So this is what we mean by this. You are allowed to have one unknown dimension. meaning that you do not have to specify an exact number for one of the dimension in the reshape method. Person minus one at the value and numpy will calculate the dimension. So person minus one here, numpy automatically calculate the dimension, which is 2 by 4. So it is still something I type for here. It will create it for me. But sometimes,
Sorry.
yes.
Sorry, sir. This last one, I did not get it correctly.
Which one?
This minus one, the one you see when you define the first element, you don't need, when you write minus one, Python will detect.
Okay, let's go on. So do you understand here we have 2 by 4?
Yes, sir.
Now, so here we have 2 by 4, which is because we know this is 2 we know this is, you can change it 2 by 4. But sometimes you only need 2 rows, right? You only need 2 this way, but you may not know because maybe the array is so large that you cannot specify the exact number. You want to numpy to automatically calculate what that number means. So for example, this one is 1 million. It's 1 million. Do you understand? It's 1 million into it. But I just want to have 2 by some stuff that I don't know. So what you need to do is just put -1. What you are interested always is this. You, when you are doing calculation, for example, is matrix, you want to change the dimension here to just become 2. And here it be anything, you don't, let it be anything. But what you want to confirm this dimension from here to be 2. Then you can specify -1, numpy will automatically figure out what the other dimension. So here numpy automatically figure out to be 2 by 4. But what about if I remove here 2 entries here, for example? So here numpy will automatically configure that it will be by 3. Instead for me to type, I need it to be 2 by 3. So here it is. For smaller number, you may know, but for large n can be 1 billion, 1 million, large matrix, you don't know what it will be. You don't know that, so you can just specify -1. Does that make sense?
Yes, sir.
Yeah, so that is the essence of that.
Okay, so thank you.
Yeah, so you can reshape, you can do that reshaping from any angle. So here I have A1 is 1 by 3. So let's look at this example so that we can. So what is A1 here? We have A1 is, who can tell me the out on the content of A1?
1 to 12.
1 to 12. Now, what about this one? What will give me this one? A1 the reshape 3 by 4. What will happen?
It will reshape it into a 3 by 4.
3 by 4, right? Okay, 3 by 4. So you can see we have 3 by 4, right? But if you don't know, for example, for large NO, you only care about the shape here, the 4, but you don't care about this. So you can specify here -1, 4. So this one and this one are still the same thing. It will just automatically reshape it. So you can see here, you are still the same thing. Can you see that? So this is still the same example. Any question before we continue? Flattening array or Ravo. So flattening array means converting multidimensional array into 1D. Flat array. If we have this array, we can flat it to become 1D. We can use -1. So here, if you look at this one, you can see here I have an array. So here you can see I have array which is 2D, right? This array is 2D, right? This is 2D, right?
Yes.
Okay, now I can plot it. What I mean by plot it is to, when I array the reshape, I put -1 only, it will become into 1D. Let's look at what will happen. Okay, new array, write this one. Okay, print new array. Right, can you see 1, 2, 3, 4, 5, 6? I plot it, it becomes like this. But what is array originally? Let's look at array originally. Let's remove this. The array originally is this. Can you see it? 1, 2, 3, 2 by 3. This is our array 2 by 3. But we can plot it to become only this one. So here we use -1 when we want flat array. So we flat it this way. But not only this user reshape a -1, we can use a function called, you see, the ravel when we call ravel here on this, what it will do is it will flat it. So here it means these two and these are the same. So either one, you can use -1 or you can use this function. Can you see they are the same order? So if you don't specify any parameter, ravel will flatten ravel along the row. So we have one thing. So here, if you look at it here, 1, 2, 3, 4, 5, we flatten along the row, right? We flatten along the row. But let's look at one here. So let's look at something here. Here, if you look at it here, flattening works along the row by default, the 0 dimension, so it will flatten along this way. But when we flatten we order by F, it will do by column. Let's look at what will be this one. Okay, let me comment this one, these guys. So let me run this one. So look at what will happen here. So you can see here 1, flatten 1, and by column, then 4. Can you see 1 by 4? 2, then another column 2, 2, 5. 3, then it takes another column 3, 4, 6, which is different from this one, which is 1, 2, 3, 4. It just takes them in seriata 1, 2, 3, 4, 5, 6. But when you specify an order, it means you are taking them, flattening them by column. So 1 by 4, can you see? You put them, you are flattening them, but you are taking them considering the column the way they come. So does that make sense?
Yes, sir.
Okay. Any question? So you can also reshape it along different dimensions. By default, reshape do reshaping along the 0 dimension. That is the row when we say 0 dimension. But this behavior can be changed by changing the value. So let me explain this one as well. So you can see here, arrange. Let me see what is my arrange here. No, guy, not you. So here I have A1. So here, for example, I have A1. What is our A1? So this is A1 is 1, 2, up to 12. But when I say reshape A1, what does that mean? So when I do reshape, right, okay. When I do reshape, it means I'm reshaping to 3 by 4. So how this reshaping works? Look at it, how the reshaping works. Print A. Let's look at how the reshaping works. So if you look at it here, the reshaping works this way. It takes as 1, 2, 3, 4. It reaches here. Then it goes to the next line. 5, 6, 7, 8. It goes to the next line. 9, 10, up to 12. Can you see how it works? But what about if this is not how you want it not a row, but in column, so that here it will be 1, 2, 3, 4, 5, 6, 7. Do you understand what I'm saying? That way, it means we need to specify the order. So this is the order. For you to do, you say A1 the reshape 3 by 4 here, then the order is F. Let's look at what will happen now here. So let's see this. So can you see now it's 1, 2, 3, 4, 5, 6, 7, 8. Does that make sense?
Yes, sir.
So this is what is called reshaping along different dimensions. So you can reshape along the row dimension, you can reshape along the column dimension. So yeah, so now we are moving to the, I think one of the basic of the Numpy, which is the last one, array concatenation. So what do you mean by concatenation in Python? Who can help us? What do you mean by concatenation in Python?
Adding two arrays. Adding them together.
Right? So all of the preceding work on single array. So all what we have seen work on single array. So we can combine multiple arrays. So this is what we want to see. So here you have an array. Here you have an array, and we want to concatenate them. Previously, we have not seen how we concatenate an array, right? So here we concatenate them 1, 2, 3. Can you see that? Then here we have 3, 4. Can you see that? We say X and Y. We concatenate them. But the concatenation can be taken as tuple. This is tuple, right? Because X and Y, we put this. What is the difference between this one and this? Who can tell me? Difference between this and this. What is the difference between the two?
Well, the first, they are the same.
What is the difference between this one and this? Who can tell us?
The first one is a list, while the second one is the tuple.
Okay, it's a tuple. So concatenation.
But in terms of the
so concatenation can be done with both tuple and a list. You can do that. So here we said we pass a sequence of array that we want to join to the concate function along with the axis. Either axis, okay, we concatenate and take a tuple or a list as the first argument. So this is just to make sure you understand. So here we can also concatenate. You can see we concatenate. But who can tell us along which axis now are we concatenating? So because like now we have 1, 2, 3, we have 3, 2, 1. We are concatenating along which axis? Because like when we concatenate 1, 2, 3, the remaining one continue on this 2, 3, 2, 1. Also here we create another new variable called z, which is 999. And when we concatenate x, y, and z, it just continues. So which axis are we concatenating now? Who can help us?
The row axis.
In 0 axis, exactly, which is basically row. So here we can concatenate also two-dimensional. So you can see here we have 1, 2, 3, 4, 5, 6, which is grid. And so here we can say grid by grid, we concatenate the same thing. 1, 2, 3, 4, 5, 6, 1, 2, 3, 4. So it's concatenated. So right. But when you want to concatenate along the along the column, one axis. So you can see, let's look at what will happen here. So look at this one. When we say, okay, concatenate along axis 1. So you can see 1, 2, 3, right? 1, 2, 3. But we are concatenating with another one, grid. 1, 2, 3. Can you see? So it concatenated along here, not along the row. So that is concatenation. So also you can use V stack and NP stack to do concatenation. So if you have array with different kind of dimension, you can use this to actually concatenate them. So let's move on. Splitting array. So what do we mean also by splitting array? Splitting array allows you to split your arrays. What do we mean by splitting? So here we have an array, and I want to split this array into, for example, 2. So let me use this this one. So here I have an array 1. I want to split this array into 2, divided it into 2. So here I can say, okay, NP the split. I say this is the array. This is 3. I say here x1 and x2. So here I provide a single number as a list inside here, but it means it is dividing into n plus 1. So when you give one number, then you're gonna have 2 sub arrays. When you provide 3 numbers, then you are getting 3. That is n split point to lead to n plus 1 sub arrays. N split point lead to n plus 1. So here you can see I'm splitting by only one number, that is from 0, 1, 2, 3. Then I will have something from here to here and have something from here to here. So let's look at, so since you are having 2 subarrays, then you need to specify, okay, x1 will take the first one, x2 will take the second one. So this is how in Python, if you have 2 variables, 2 results, you can put the 2 results into this format. So let's look at what this means. So you can see, let's look at what is x1. Okay, let's say print x1. Okay, let me use this one. Print x1 and x2. Can you see? 1, 2, 3. So you can see here, we have an array x, and we say, okay, we give 3 here. It means it's splitting from 0, 1, 2, 0, 1, 2, 3, but it will not be inclusive, right? So these are the elements, but the other ones are here. So here you can see this is assignment, because this thing return how many elements? Return 2. So here you need to specify 2 variables separated by comma. The first one, which is this, take this, x1, take this. You can also, if we have x, 3, and 5, it means we're going to have 3 elements, 3 sub-arrays, x1, x2. So this will give us also 3 sub-arrays, as we can see here. So you can see here we have 3. Can you see that? Great. All right. So that is how that is done. So this is also another split, this split, which is actually splitted. Yes, question?
The last one you just did, can you please come again?
Which one? This one?
Yes, the one with 3.
With 3. Okay. So here we can see NP the split. How many numbers do we input here inside the list here we want to split? 2 numbers, right?
Yes.
So it means we're gonna have how many subarrays?
3.
3. So here it means the 3 here, it means start from the beginning and stop at 3. So here it means this is telling us start from 0 and stop at what? 2. Now that is the first one. And this one here, it means start from 3 and stop at what? 5. Right? And the last one telling us start from 5 and stop at what? End. So here we have 3 elements, 3 subarrays. So 0 to 2 is this. We assign to x1. 3 to 5 is this. 9, and this one, we have this. Then 5 to n, that is 0, 1, 2, 3, 4, 5. That is start from 3 to n. Does that make sense?
Yes, I understand.
Okay, cool. Right. So let's go on. So here also we have split. We have this one is what is the shape of this one? Who can tell me the shape of this one?
It's 4 by 4.
4 by 4, right?
Yes.
Okay.
Yes.
So now I want to split this one. Now the splitting, am I going to split like this? And this, or am I going to split like this, taking from here to here? So that is what is called V split, and that is what is called head split. V split along the column, and this head split. So let's look at it. So here we say NP, which is NumPy, V split. Remember, NP we always call for any function in the NumPy, because we say import NumPy as NP. So V split is a function inside NumPy. So before we call it, we must call NP dot. So here we said we want to V split. So who can guess now what will be the lower, the upper? What will be the upper? What will be the lower? Who can tell us here? Who can guess? What can be the upper subarray and lower subarray?
The upper will be the first 2 rows.
Okay, let's look at what that means. Can you see 0, 1, 2, 3, 4, 5, 6, 7? That is the upper. So here we are using this NP split V. But the other one, H split, then it is taking us. Can you see that? So it's taking us like this, 0, 1, 2, 0, 1, 4, 5, 8, 9. So you can see it's split it along this way, this and this, and the second one, it starts from here. So these are 2 things. So when we say V split, it means it is splitting actually along the rows, right? Don't get confused. When we say split along the column, we say V, it means it's actually dropping the column and using row. So here when we say H, we are actually not splitting along the row, but we're actually splitting along the column. So this is 2 things that you should. Right. So we finished with basic Python, basic NumPy, and now we'll look at some of the important stuff that NumPy brings. So we now discuss the nuts and bolts of NumPy. We'll dive into the reason that NumPy is important in Python data science. So we now look at how we can do many things in NumPy. So NumPy actually, as we said, it provides fast operation. That is why it is created. And this all these fast operations are implemented using what is called onfunction. So onfunction is universal function. So this is the most important things NumPy provide. NumPy provide what is called vectorized operations. Let me show you this example. So here I have A, I have B. Now, what will be the result of this one? Who can tell me? A by B, what will be the result?
2, 2.
Eh?
2, 2.
2, 2?
Yes.
Yes, that is 2/1, 4/2.
Okay, this is in Python. That is correct. In Python, it will give me 2/1, but are you're gonna be surprised that Python doesn't know this? Python is so dumb in this case. So when we write this gives us an error. Python don't even understand this.
So you mean NumPy?
Python, I mean Python. You cannot do this division in Python. Can you? Try it yourself and see. Here I have A, I have B. Now I want to divide A by B. I should have like 2/1, 2, 4/2, give me 2, where I have 2, 2.
Okay.
Python does not allow this. This is Python, it's not NumPy. This division is NumPy in Python, not the NumPy. But R programming, one of the good thing in R, and what is I really enjoy with R, is that R operations, they are vectorized by default. So here Python by default is not vector. So let me give you an example here. This I have R console here. So let me give you an example. So all right, let me. Okay. Okay, let me see. Okay, so you can see here I have x equals to what is x. Can you see my screen here?
Yes.
Okay, now I have x equals to this. This is y. This is r. So in R assignment, y equals to this. We use this sign to show as an assignment. So this is what. So in R, now we can say x plus y. And it plus 1 plus 6, 7. 2 plus 7 gives 3 plus 8 gives us. But Python is dumb. Python cannot do this addition. Do you understand what I mean? So this is what I mean. If you look at this one here, yeah. So you can see here. So also here, like this one here, I say A is equals to 2/4. So let's look at this way. I create a list here, something like that. So I can say, okay, A equals to 2. I have 4 here. So this is okay. And here what I have 1 and 2, right? So let me create another variable for B. Now B is 1 and 2, 1 and 2, 1 and 2. Okay, so it means now here I have A equals to 2 and 4, and I have B equals to 1 and 2. So I can say A divided by B. Can you see, give me 2 we expected? Can you see that?
Yes.
So this is called vectorization. What this means is that if you have something like this, when you do addition, then that is called vectorization. It will propagate to all other sections, to all other things. So in vectorization, if you use vectorization, this one will be to this one, this one will be to this one, but Python does not support vectorization. This is one of the grand reasons why NumPy come into being, to save us from this dilemma in Python. So here we say NumPy provides vectorized operation. So it means Python does not have vectorized operation at all. This vectorized operation leads to much faster execution. So for you to do this kind of addition in Python, you may need to implement maybe some kind of loop, or even what do we call this one? Loop or the other one that we discussed that you don't need to use loop. What do you call it? So in some way, let me just say it. In some way, in Python, you cannot just use what I've shown in R. So you can. So similar to R, many operations in R is vectorized. This allows to write cluster code. So this means that this is not feasible in Python. So Numpy comes to rescue it. But look at it here. I say np.arrange 1 to 6. This is telling me what is okay. Let me show you this. Let me have this np.arrange and np.arrange 1 to 6. Okay. So what is this? The first one np.arrange is 1 to 5. That is correct. Is that right?
Yes.
What about the second one?
1 to 6.
1 to 5 without 6 inclusive, right?
Yes.
Now, how many elements? Each one of them has how many elements?
5.
5. Now, then we can do this here. Let's look at it. Let me do it. Print and print here also. Okay, so let's see. Okay, so you can see this one is 0, 1, 2, the first one. So here it will say 0 divided by 1, 0. 1 divided by 2, 0 0.5. 2 divided by 3, 0 0.6. 3 divided by 4, this one. 4 divided by 5, it gives us 0 0.8. Now, this is called broadcasting. We cannot do this in Python at all. As we have seen here in Python, we cannot do division like this. We cannot say A divided by B. But in Numpy, that is one of the reasons why Numpy comes into rescue. So also,
Sir,
yes.
Is broadcasting the same thing as vectorization?
No. So we'll see broadcasting later in Numpy. So broadcasting is different. So vectorization is what powers broadcasting. Do you understand? Vectorization is what powers broadcasting. Without vectorization, you cannot do broadcasting. So
okay.
Broadcasting, we will see broadcasting later. Yeah. So here also, you can see with this, so we have np.arrange, here we have 3 by 4, here. Let me show you this. Here we have x. And our x is 0, 1, 2, 3, 4, up to this. But we can do this like this, 2 by this. So when we say 2 by this, then it means any element here in the will be multiplied by 2. So can you see any element is multiplied by 2? So there is an idea of broadcasting that will come, but now here what we are trying to understand is what vectorization leads to. So you can see here, computation using vectorization through unfuncs are nearly always more efficient than their counterpart implemented in Python using loop. So you can see here, for you to do this kind of, to multiply any element here in this multi-dimensional array in Python, you need to use loop to do multiplication. But with vectorization, you don't need. Especially as the array grow inside, anytime you see such loop in Python space, you should consider whether it can be replaced with vectorized expression. So let's look at what let's look at okay, this is the example we have seen now, right? This is the example we have seen, so we can do this division. Can you see previously using Python, we cannot do this 2 by 4, you can see, but now we create this A and B are Numpy ND array, and they can do the division. Yeah, right. So all these ones as well. So this, you can see this plus, minus, multiplication. All this one that you see we are using with Numpy ND array, they are not addition of Python. Just take this one. they are not addition of Python, a normal addition by Python. It's addition in NumPy, because this division is not division in Python, but division with NumPy object. So here we can see you can do plus, for example, x divided by 5. If we have an array, this is x. Can you see this is x is 0, 1, 2, 3, 4, 5. But when I say x plus 5, it means any element, all the elements, add them plus 5. So you can see 0 plus 5 plus 5, 1 plus 5, 6, x minus 5, 0 minus 5. You can see all this one is vectorized operation. But this addition and subtraction, remember, they are not Python addition subtraction. What is happening under the hood? If I said x plus 5, if I say x plus 5, what is really happening is this. Look at what is really happening. What is really happening? This is what is happening. It is that addition is calling np.add in NumPy. So all of these arithmetic operations are simply convenient wrappers around specific function built into NumPy. So for example, the plus operator is a wrapper for the add function. Do you know what is called a wrapper in programming? Do you know what is called a wrapper?
Yes.
So this is telling us that.
No, sir.
Okay, no. So this is telling you that, okay, now a wrapper is something like this. If I have, for example, addition in Python, basically when I say 1 plus 2, 1 plus 3, in Python, 1 plus 3, what it does, it do addition, right?
Yes.
So we can write a wrapper that is something that encapsulates the behavior of addition. At the bottom is you only see addition. I'm adding 1 plus 2, but under the hood, this addition is calling one method called add to do the addition. So let's look at this help np.add. Let's look at this. So this add method, what is this? Okay. You can see that x1 and x2 are if s1, okay, this is telling you Dogon Turangi. This is Dogon Turangi. So basically, what is telling you that add is a function that serves as a wrapper for addition. So when I said 1 plus 2 in NumPy, not in Python, and NumPy, when I say 1 plus 2 in NumPy, not in Python, it's calling add, which does vectorization, because the add for Python does not do vectorization. So instead for it to call plus for Python, which does not, then in NumPy, if the object, if 1 and 3 are NumPy objects, then it will not call the plus addition for basic Python. It will call the wrapper add to do the addition in NumPy, which support vectorization. I don't know if that makes sense.
Yes, sir, it's clear.
Right. Okay, so you can see here and np.add x plus 2. So here, okay, let me show you this. So here, when I say x plus 2, let's look at what will happen. And yeah, let me print this, print this, and print this as well. Print. Can you see the two are all the same? When I say x plus 2, it gives me the. When I say np.add, I put x and 2, it gives me. So here, this add is calling at the background, is calling this method add to do the addition, because this addition is implemented in NumPy to support vectorization. So this is just the basic idea. So also here, there are some stuff like this. When we have this array, NumPy array, and I call absolute value in x, it gives me the absolute. When we say absolute, it means it gives me the absolute value without minus. So you can see, just as NumPy understands Python built-in arithmetic operation, it also understands Python built-in absolute value. So here it's absolute value for Python. So these are many mathematical operations. Numpy also provides many mathematical operations. So here you can find, for example, theta, sine, cos, tan. All of these operations, we will see them in future. So here you can see you have a theta, you generate some values. The number values, you save them at this. Let's see what is theta. So you can see this is theta, it's an array with some value 0, this. So here we can calculate the, for example, sine and stuff like that. So you can see theta is this value, the sine of theta. So this, you look at the importance of vectorization. When I say sine of theta, it's telling me the sine of this, it's giving me the sine of this, it's giving me the sine of this. So these are the sine of this. When I say np dot cos theta, because theta, it includes 3 elements, 1, 2, 3. It will calculate all the cos of each one. np dot tan, it calculate all the tan of elements. So you can see, if you are using Python, you need to write loop to calculate for each one. Does that make sense, this one?
It makes sense.
Right. So here also you can see we have x equals -1, 0, and 1. And here we are saying, okay, np dot arcsine, np, a lot of them, then it is calculated in all the elements -1, 0. This is called vectorization. So you can do exponent, many things, and this is x and exponential of x. We have np x 2 power. So this is 2 power x is exponent 2. This is a numpy function. 3 power, this power, we can call this, all these one are provided by numpy. So as we see many of them, just now to understand all these functions. The log also, numpy comes with log function. So here we have log, logarithm, it will give us a logarithm. Right, so here we have other aggregate functions. So I don't know, it's already 3:37, but we're supposed to finish this one. How do you think we can finish? Because tomorrow, the next week, from Monday to Friday, we will solve 100 questions for NumPy. 100 questions for NumPy, so that you will solidify your understanding of NumPy. But I want us to finish some other sections. How can we do that? So here, there is what is called aggregate functions. Aggregate. So let's look at this one. We all know what arrange does, right? So we have np.arrange. Let me show you. np.arrange. So np.arrange, it gives us these values. But what when we call this one? np.add and reduce. So reduce repeatedly applies a given operation to the element of an array. So it means here it will say add this plus this plus this plus this plus this. It will reduce to particular number. So you can see it give me 15. Add, reduce. This reduce function, what it does is that it produces repeatedly some operation on some stuff. But this we can insert for that, we can call np.sum x. We give you this. Can you see np.sum give me 15? But just be aware of this reduce function. It will actually apply this add to repeatedly to the sum. So here also we have multiply, it will do the same thing. But what about if, because you can see reduce here, it will only give you the result. But what about accumulate? Accumulate is a function that allows you to see the stop. So here you can see we have our np.range. So, okay, let me show us this. So you can see here we have 1, 2, 3, 4, 5, 6. So, but accumulate shows give you the result. So here we have 1, but the next one, it gives showing you like the result. So here we have accumulate here, it shows the result. So here we can see that 1 plus 1 is this, but 2 is this. But when we say 1 plus 2, it gives us what? 3, right? So the result of this plus the next one, 3, will give us 6. Now 6 plus the here is I'm doing multiplication, sorry. So 1 times 1 is 1, but 2 times 1 is 2, right? But the result, 3 times 2 is 6, it will give me this result. 4 times 6 will give me 24. 24 times 5, it give me 120. That is accumulate. So these are different functions. You will understand. Don't bother about this function. when you come to use them, you'll understand what they mean. So here we have sum function, which we have seen. It basically use the same thing with Python sum. It basically do summation. Max basically return the maximum value, which we all know is so trivial. Minimum return something which is minimum. Yeah, so so I think we have many things, but yeah, so this is where we will need to continue from computation on broadcast. But I think I need to go through these examples because this will be maybe okay. Let me, because I skip it. Just wait for a minute. We will finish aggregating a function. So let me show you this one. Aggregation, that is minimum, maximum, and everything in between. So what we mean by aggregating, that they aggregate the result. So let's look at what is L. Now here we have L, which is random number, and look at the result. This is a random number from 1000. We generate how many number? But what we are saying here is that we can do summation. So when we see sum L, when we see sum L, this one, and when we call NP the sum L, this is Python, summation in Python, because you remember in Python, we have sum function, right? But this is summation in what? Numpy. This is summation in Numpy. So, but what is happening is that the difference between the two is that one is faster than the other. Let's look at it. Let's look at it. What is the meaning of this time it? Who can tell us time it? What is the function of time it?
It tells us about the running time of.
Exactly. So here I create big array, random number, 10,000, 1 million, I think. So I do summation in Python and I do summation in Numpy. Let's look at what will happen. So you can see the time, the Python summation text. Look at the time, the Numpy summation text, just 3.35 milliseconds. But this one, look at it. So you can see the time is so different. So we should always use summation from Numpy. But for us to do, remember, we must call NP the sum. So we have another one, which is max. So this basically tells you what is the maximum number. Can you see that? So look at it. Yeah, I want to, this is for Python, minimum and maximum, but this is for what? Numpy, because NP did mean, NP did max. Can you see that? So look at another thing is like, I separated this one by comma, but it turns something like this. The output, you can see it looks like tuple, right? Because remember I said tuple is separated by comma. So the output it returns inside with closed braces. Can you see that? Because if you remember here, I want to calculate I want to push out the tuple. You remember tuple here? So when I calculate this, can you see it give it inside a tuple? But even when I do not include this open and close bracket, I just put two numbers and with comma in between them. This is tuple in Python. So you can see it include them in tuple. So yeah, so this is just, you can see the time it takes. Each one we can see it takes a longer time. So this is it. Yeah, so this is summation. Okay, this is another thing, random. This is something. Okay, so you can see here we have M, which is random numbers, 3 by 4, but we can do summation. Now, when I say summation, this summation is sum everything in the array. But sometimes you want to sum values here, a column, sum this one and this one and this one and this one, or sum along the row. Can you see it? How can we do that? So this is how it is done. M.min axis is 0, sum along the row. Or sum max axis 1, sum along the column. So this one will sum along the row, this one will sum along the column. So this is summation along the row, this summation along the row. Remember, they all always give us a single number, but that it is always along the row or column. So I think we can stop here. And I don't know, what do you think we can meet up, finish the broadcast, because I don't want to the final session, this broadcasting to take us to another week. What we'll be discussing pandas. So how do you think we can finish this section?
Maybe we should deliberate within the week. We can spare maybe 1 hour or 30 minutes.
Yes, 1 hour or something like that. Yeah.
And we can do it in the night, I think.
In the night, right?
Yes.
Yes, I think, what about 8 o'clock? Can you come over at 8 o'clock? We can do it. We can finish at 8. So we have some stuff. It's just like some section, but it is too difficult now to continue because we have like 1 hour, 30 minutes. So are you okay? Like 8 p.m. we can finish that?
Yes, it is okay.
It's okay?
Okay.
Okay. So please come 8 p.m. 8 p.m. We can finish it. It will not take us, I think, 1 hour. The reason why I want us to finish, the week coming, you guys, you will solve 100 Numpy examples. When you solve those 100 examples, I believe that will increase your understanding of Numpy. Yeah.
The whole 100 within 1 week?
No, the whole 100 each day. They are just simple. For example, the first one I will give you, how can you import Numpy? Do you understand? So it's not something difficult. How can you do addition of it? So it's something that if you sit down each and every day, I think I will see how it works. So we may not do the 100, I think, but it depends. So daily I will put like maybe 10 questions, practice questions daily from today to the next week. I'll put some questions that you practice yourself. Do this practice, it will help you. The only way we can perfect this stuff is through practicing ourselves. So yeah, so see you later in the day.
Thank you.
Okay, bye-bye.
Okay, thanks.
Bye.
Thank you so much.